And we are live. Okay, great. But I think those little boxes will come off. Okay, perfect. They are off for sure. So I'll give the attendees, as they're coming back from their break, and I hope they had some good snacks that they would probably share with us, hopefully.
Yeah,
I would love
snacks.
I would love if Andre could have shared some of his snacks with me, but I know he's not very close by. But I hope you all had a good break session and a good session just taking in everybody else, all of the other great speakers, panelists. Like there's been a lot, a lot. And Ben is here too. Great. So we have Ben. Oh, we have Ben, so we could start. Yeah.
Some of the catering was a little tricky for this event.
Oh boy, yeah. Yeah, we have to get that catering sorted out. So I'm gonna give the attendees a little bit of time again to come in and, you know. Oh yes, Andre, you're in charge of snacks for the next time.
That's a tough one right there.
Yes, it is. And he's in Canada, so it better not be cold by the time he gets here. So I'll give the attendees a little bit of time again. I know the break times, people are like catching up on all of their emails and calls and all of these great things. Your Queen is here with us. Great. Perfect. And I love that because we have another Trudy in the room. So now we have the party has started. Right. So we have a lot of Caribbean people in the room. Love that. Love it. So we are going to get started. Yeah, there are a lot of great presentations so far. A lot of great presentations. And we have another great presentation with us. So we have Israel Sanchez, who is the mechanical engineer, and Kyle McGhee, who is the predictive maintenance analyst. Now that's a mouthful to say. And they both work for BELCO, which is the Bermuda Electric Light Company. So based in the Caribbean, yay. They are going to be telling us a little bit more about BELCO's condition monitoring program. So I am very interested to hear about this, and I know you all are going to take me through it. So I'm going to pass the stage over to Israel and Kyle. You all have the floor.
All right. Thank you, Sonia. I feel like you could have done the presentation for us at that point.
I'll try.
So let's just get started here. If my presentation would move, here we go. So yeah, as Sonia mentioned, we'll be doing a quick run through of BELCO's condition monitoring program. So BELCO is the Bermuda Electric Light Company. Sonia did mention my name is Israel Sanchez. This is Kyle McGhee. We'll be doing a brief agenda, safety moment, and then we'll get into a more detailed introduction of ourselves, of the company, and of the island that we live on. So quick agenda. We're going to do a safety moment. That's pretty customary for any meeting here at BELCO. We're going to do the introduction that we mentioned. We'll look at an overview of the condition monitoring program, and then we'll look at some brief case studies, some of the experiences that we've had. And then, of course, we'll be able to take any questions that you might have. So Kyle will do the safety moment.
So our safety moment for today is avoiding heat stress, which happens here and a lot of other countries some of us are from. Some tips to avoid the heat stress is to stay hydrated, avoid dehydrating liquids such as coffee, which I know is difficult, wear protective clothing, pace yourself, schedule frequent breaks, especially water breaks, and just in general, protect yourself from the sun.
Right, there we go. So for a brief introduction, again, my name is Israel Sanchez. I'm a mechanical engineer on the bulk generation team here at BELCO.
And I'm Kyle McGhee, predictive maintenance analyst, also with bulk generation.
For a quick breakdown of what the company looks like, very, very top level. BELCO consists of BG and TD&R, so bulk generation and transmission, distribution, and retail. Under BG, there is OHSE, so that's occupational health, safety, and environment. There's procurement and logistics, and then there's bulk generation, which is basically the power plant. We'll say that. Under bulk generation, there is operations, engineering, and production. Under the production team is the electrical and instrumentation maintenance team, mechanical maintenance, and system reliability. So we're here on the right side of this little graph here in terms of the organization. For an introduction to Bermuda, we're a pretty small island. We're 21 square miles, about 1,000 kilometers from North Carolina, right here in the middle of the Atlantic. We have a population of just about 64,000 right now at last count. Peak electric load is around 100 megawatts, give or take. And a few things that people might be aware of already is, yes, Bermuda shorts. They're part of the traditional attire. You'll see these dapper gentlemen here with the whole outfit. We're not wearing that, unfortunately, right now, as much as we wish we would. And yes, like the triangle. So we are one of the corners of the Bermuda Triangle, along with Miami and San Juan. So we're also in the middle of the Atlantic. So of course, hurricanes are a thing that affects us pretty frequently. So we just had one last week and we're hoping one doesn't hit us while we're presenting right now. I don't think there's anything on the map though, so we should be good. In terms of an introduction, a little bit more of the details. In terms of the generation side, plant capacity nameplate is about 142 megawatts. The equipment that we use is 8 MAN reciprocating units. So those are 4-stroke engines. They're about 14.5 megawatts each. We also have 3 Centrex gas turbine units. Those are aeroderivative units, about 5 megawatts each. We also have 1 ABB gas turbine unit. That's an industrial frame unit that does about 15 megawatts. And then there's also a SAFT battery energy storage system, which can do 5 megawatts for 30 minutes. So that comes out to around 10 megawatt hours. Our annual production, 560 gigawatt hours. The type of fuel we use is an intermediate fuel oil and diesel, and the generation is done at 13.8 kV at 60 hertz. We're the only ISO 14001 environmental management system certified company in Bermuda. Now, moving out of the plant, we have around 36,000 metered connections on the grid, 34 substations. We transmit at 33 or 22 kV, depending on which switchboard we're going to, which parts of the island we're feeding. We distribute at 4160 volt overhead lines. There is some underground as well. And residential voltage is 120 volts, which I think most of us would be familiar with. Third parties on the grid as well. There is a 6 megawatt solar plant, about 10 megawatts of distributed solar on the grid, on people's rooftops. And there's a 5 megawatt capacity waste to energy plant that is also on the grid. In terms of layout, you'll see that we're in a pretty residential area. We're pretty well known for the white roofs, so you'll see those. That's pretty much all residential. So on the east, of course, is the East Power Station that houses 4 of the reciprocating units. The North Power Station houses 4 of the new ones as well. The West Power Station contains the gas turbine units that we talked about, as well as the battery energy storage system here. And I think also of note here, even though this is a little bit old of a picture, is the old power station. We used to have some reciprocating units in there as well, but that plant has been decommissioned at this point. So currently this is a pile of rubble. This building isn't here anymore, unfortunately, but figured it was nice to point out. So we'll look at the condition monitoring program now. So the system reliability team, Kyle's a key part of that team. They use a variety of predictive technologies as a key part of BELCO's reliability-centered maintenance. This isn't an exhaustive list, but it should give you an idea. So that includes vibration analysis, infrared, ultrasound, transient earth voltage, partial discharge, combustion analysis, ultrasonic volt measurement, and motion amplification.
So the main part of our condition monitoring program is mostly vibration. We check vibration on a multiple piece of equipment, such as the alternator pedestal bearings, different engine auxiliaries and plant auxiliaries, such as motors, fans, pumps, separators. And we do this on a 90-day schedule. We check over 200 assets plant-wide. And we also use our vibration analysis to check the engine foundation vibration, and we do that on a 3-month cycle. As well as that, we use ultrasound, and we do that in parallel with our vibration measurements, and we generally look at bearing defects with that.
In addition to that, infrared thermography is a pretty key part of the program. This is done for bulk generation as well as for transmission and distribution. On the transmission and distribution side, the system reliability team looks at poles, volts, transformers. On the bulk generation side, they mainly look at MCC buckets, motor connections, and that's done via infrared windows. This is done on a quarterly basis. And here we'll see some examples of some areas where we saw hotspots on different phases, on different connections that would signify that there are issues with the connection or with the system.
Another thing that we check for around the plant is partial discharge, and as well as in the distribution network. The HV and MV switchgear around the plant, we check monthly, and then around the island, we check each substation on a weekly rotation, and it usually takes us about a year to get through all of them, so we check them annually. As well as that, our reciprocating generators have continuous online monitoring for partial discharge. As well as that, we do combustion analysis on each of the reciprocating engines. We measure each cylinder's combustion pressure and timing, and it overlays them into a nice graph. We do this every 30 days at a fixed load, and we look for things such as faulty injectors, incorrect timings, bad atomization, pressure deviations, power balance, leakage, and a lot more that it can tell us.
So anybody here from BELCO will remember D14. This is the last trend that we got from D14 before it got decommissioned. Usually you want all these lines to
match up.
They really weren't on D14, and anybody who saw that engine will know why. In addition to that, ultrasonic bolt measurement. This is used to verify tension of engine foundation bolts. It's done every 6K overhaul, as well as motion amplification, which is used as requested or as part of investigations. So we do have a brief video here. Hopefully we don't have any issues with it. So this is just kind of an overview of what the motion amplification camera might show you once you filter out the frequencies that you want. So this won't be exactly what you're seeing on the units or on the equipment when you go out there and you look at them with your naked eye. But the technology helps kind of amplify the motion, as the name implies, to give a better view of what's actually happening. So we saw some of our East Power Station engines. Here's some of the North Power Station engines with some additional overlays showing what the software could do in terms of velocities and displacements. So let's go next again here. So with that said, we'll just look at some of the brief case studies, some of the past experiences that we've had.
So I'll start off. This is looking at a jacket cooling motor pump motor set failure that we identified. We used the motion amplification camera for this one. It started off where we were doing vibration readings on the motor inboard bearings. We were frequently finding them quite high. We were having multiple coupling failures with this motor. It added up to be about $12,000 of cost over 2 years. Our vibration spectrum indicated that there was misalignment, even though we know that this pump motor set was laser lined and double checked. So we used our motion amplification camera to take a video of the entire assembly, and this is what it showed us.
1 second, play the video here.
So this shows what the motion amplification camera does. The left side is a standard video that you would see of basically what you'd see with your own eyes. And then once the program amplified it, this is the type of motion that you'd see. So as you can see that the motor is moving quite a bit and the base plate is jumping up and down.
Not good, right?
This is an overlay of a phase map. This is part of the technology that it can show the phase of the movement and the vibration in each part. That's very cool technology. You can see that the motor is out of phase, should be vibrating as one. This is a zoomed in view of this bolt, and as you can see that the bolt is loose. It's hard to tell with the naked eye, but with the video it's quite clear. And then this is the back of the base plate. You can see that the structure it's mounted on isn't very rigid. It's very flexible, giving it a lot of room to move. So our recommendations were to retighten all the base bolts, add additional support there to make it more rigid, and yeah. After that, we got them to install lateral supports on the skid. The vibration readings in the motor have been lower consistently since, and we have not had a single coupling failure since. So this case study highlights the importance of trending and accurate analysis and proper documented maintenance history, so we can notice that we are having multiple failures with this motor, and we can address it with the root cause analysis.
The next one we'll talk about has to do with the battery energy storage system that we talked about earlier. So the system was commissioned in 2019 to shift spinner reserve from running engines. A predictive maintenance routine was created to check the transformer cable connections monthly via TEV and ultrasound, so transient earth voltage and ultrasound. And around July, August 2021, some partial discharge signatures were being observed, specifically from the ultrasound side. The OEM was engaged due to the warranty and service agreements, and then we de-energize and open up the cable boxes. So immediately, the first thing you could see is that we have those signs of corona, of partial discharge. You have that kind of white, fibrous, powdery substance. The other thing that was immediately noticeable is that the fastening of the whole connection was a bit odd. Everything was kind of rigidly fastened against the earth frame. You could see that the insulators were deformed more than they probably should be. So in this case, it's a pretty simple fix. You clean off all the partial discharge product, you rearrange your fastening arrangement. In this case, we put an insulating spacer between the cables and the frame, and then we put it back together. So we found that improper installation, we found those signs of corona discharge, and it was a simple resolution to the issue. The discharge subsided from that point. But if undetected, those repair costs could have been quite significant, right? So again, this highlights the importance of identifying issues early to prevent significant damage to equipment. In this case, it was only some cleaning and some changes to the fastening that was needed instead of a major replacement, for example, right? You could imagine what a catastrophic failure would be on a piece of equipment like this. The next one we'll talk about is stator frame cracks on one of our engines, E7. In this case, there were some concerning vibration trends being found by Kyle's team on the pedestal bearing. So you can see from the vertical vibration spectrum here that there were some odd spikes, and then eventually we started seeing the values going up pretty consistently. So again, not a good thing. So we open up the unit for inspection, and what do we find? We find quite a few cracks on the unit, on the stator frame. Usually want your stator frames to be pretty solid piece of equipment, right? You don't want these things falling apart and vibrating. So we had to carry out a metal stitching operation from this point. So in this case, you drill out your holes as needed, you hammer in your locks into place, you drill in your lock patterns, you make sure that they're in properly. You put in some pins in place as well to prevent any future movement, any future vibration to that specific area. And then once that's done, you can grind everything down and clean it up and paint it up nicely until you can't even tell the difference. So we can see from the vibration readings after that point that the readings improved significantly. We didn't see that level of vibration again. But from there, a preventive maintenance routine, so a PM, was instituted to check this every 3,000 hours, including a dye penetrant test to check for cracks again. A similar issue was then found and repaired on the sister engine, E8, as a result, and a potential catastrophic failure was avoided. Again, this highlights the importance of identifying issues early to prevent significant damage to equipment. We don't really want to find out what happens if you don't catch this early and you let it progress to the point where something fails catastrophically. The next one we'll talk about is about some engine vibration on another engine in East Power Station, which we call E6. So to give you a quick layout and rundown of what the assembly looks like, you have the engine and the alternator rigidly coupled together. They're held down with foundation bolts that go into the seismic block. That seismic block sits on air springs. Those air springs sit on a separate isolated foundation, which, as the name implies, it's isolated from the main foundation slab for the building itself. That's done for vibration mitigation reasons. You might have seen in the picture earlier that we're pretty close to the neighbors, so we don't want to be shaking everybody's house, right? So at one point, plant staff were noticing higher vibration when working on the engine. So anybody on the production operations team, anybody would notice that the engines were vibrating more than normal. Cracks were being noticed on the seismic block along the engine as well. So there was an interim solution there, epoxy injection. The idea there is that you want to restore the original strength and the integrity of the structure, as much as possible. And you want to minimize corrosion and subsequent weakening of the reinforcing steel. So the steps there are you clean and you degrease and you prepare the crack surfaces, you install injection ports and you seal the crack faces, and then you inject your low viscosity resin. So a couple pictures of the aftermath once everything was completed right here. You still see the injection ports sticking out of the areas where the cracks are or were. So good news, right? Following the epoxy injection, the vibration levels decreased for approximately 3 weeks, right? At that point, we were starting to get the reports again, and the vibration trend, well, the vibration analysis showed again that the values were spiking. So the repair wasn't as effective as we had hoped. So an ultrasonic bolt measurement round was requested to check for excessively loose foundation bolts as another potential source of the issue. And Kyle was actually the one doing this round, and he noticed a suspicious negative elongation in a bolt. Kind of odd. What could that be? So to give another brief overview, cross-section of the seismic block here, you see the engine up top, the foundation bolts in green, the areas where we had the cracking on the left and right there. And I would suggest we pay attention to this bottom side on how everything's assembled at the bottom. So we found that negative reading, well, Kyle found that negative reading, goes downstairs into the basement and takes a look. And what do we find? We find a whole bolt assembly had basically structurally failed. There's quite a bit of corrosion, and it doesn't look good, right? It's not a good thing. That's pretty clear to see. The engine from that point was forced out per the OEM's directive. At this point, there's a major repair project carried out. All the pipe work got disconnected from the engine. The engine and the alternator were decoupled. The engine itself had to be lifted around 1 meter and placed on supporting brackets. All the corroded foundation bolts had to be removed and replaced. So that included sliding the engine horizontally. All the old chuck fast, so the grouting was removed. The compromised concrete under that was removed as well. So that's due to oil saturation and cracks. From that point, the engine was realigned, well, with the alternator, and then the chuck fast of the grouting was replaced. So a few assorted photos here. On the left, we see some of the disconnections that were made. In the middle, there's some of the lifting activities. And on the right, there's some of the work that was being carried out on the foundation itself. Here's some views of what the sliding mechanism and activity look like to be able to actually get those foundation bolts out, just due to how the unit is assembled. Here's some of the kind of concrete and chuck fast pieces that were coming out. Typically, you don't want this to be coming out that easily. So of course that had to be replaced. There's some of the rebar that was exposed once we were able to get down into it. And then some more views of the various stages of the project. So here the foundation bolts were dropped down to be able to do that movement. Here's some of the chuck fast that had been removed before we had taken off most of the compromised concrete. And then on the right side, it's, once it's all wrapped up and packaged nicely with a new layer of sealant and paint with the project completed. So in this case, we could see from the vibration readings, the results and what was actually happening. So on the left side is when we were seeing that odd high vibration. We did the epoxy injection at that point. We see that the vibration decreased. And then a few weeks later, again, in addition to the reports that we were receiving from plant staff, you could see that the epoxy wasn't holding and the vibration increased again. So that big gap here is where the actual foundation repair project was carried out. And then the vibration reduced pretty significantly, and it stayed there, pretty consistently. So a more rigorous engine foundation vibration round was put into place from that point. So that's done every 3 months. There's quite a few locations that are measured in the axial, vertical, and horizontal directions. So what we learned here is that, you can have the ability to gauge the effectiveness of repairs, i.e. the epoxy injection or the actual foundation repairs. You can implement programs for early detection based on the lessons learned. And it also showed us an alternative way of using tools and technologies in addition to the original intended use. So the equipment that we use might have originally been designed for motor and pump sets, for example. So a bit of a conclusion here is that our position as the major electricity generator in Bermuda requires that critical asset availability and reliability is maximized. Our location means that lead times and shipping costs are substantially higher than larger jurisdictions. So that means that everything should be planned out as much as possible, and we should know when we're planning on doing repairs and maintenance. So the key things here is that an investment into a condition monitoring program can reduce operational costs by reducing unplanned outage duration, severity, and frequency. And then even for non-critical assets, like that first pump that we looked at where there is a redundant pump, you can reduce your costs and your downtime. So we were looking at that, what, 12,000 over a year or two, right? that can be reduced, and that's over hundreds of, pieces of equipment in the plant. So that's basically what we had to talk about. If there are any questions, I guess feel free to leave them with Sanya, and we can answer them here, or you can send us an email.
Definitely. We have no questions just yet, but that was a great presentation, because a lot of times, and it's something that we've had come up in the conference through other sessions, people are trying to justify having a condition monitoring program, or even buying like motion amplification software or any sort of hardware, anything that they need to help them with condition monitoring. And I think what you all showed in this particular entire session is that you need to invest in it before you get the results, or you see any type of results. So I'm gonna ask the question. Somebody else, Joaquin asked this question. It is clear that proper repairs done are recommended, as opposed to less remedial works. So how do you advise to engage stubborn management? And I guess what he's trying to ask here is, how do you convince management to invest in actually making proper repairs, rather than saying, I'm going for the lowest cost, the lowest price, and inferior work? So I'm gonna ask you all that question.
I'll take it.
Oh, you'll take it. Good.
Luckily here at BELCO, our program, condition monitoring program, has been going on for a while. So luckily we don't necessarily have as much of an issue with that. But my recommendations would be to, what we talked about in the pump issue was like, if you can look at the history and the cost, and you can kind of justify using that if you do these repairs, the cost over time will be less. And a good saying is, pay me now or pay me more later. And I would definitely try and use data as your backing and justification with cost. But it is tough, and I know that.
100%.
It is a struggle, Joaquin, and I know especially so within the Caribbean islands as well. And I'm glad you all mentioned the fact that things take longer to get here in terms of shipping. So planning is critical, absolutely critical. And Ryan talked about it. Ryan Chan talked about it earlier when he did his findings in the community. And shipping is still an issue throughout parts of the US and different parts of the world. So having that condition monitoring program in place, being able to identify the defects, catch them in time. Nobody wants Bermuda to go down without any lights or any sort of electricity. So it's very critical to have that condition monitoring in place. And while I may have had a little bit of motion sickness from those videos, I still very much appreciate the technology, because a lot of times we do not see what it is that's going on in the plants, and being able to understand that you have an issue, stopping it before it causes an even larger issue, that's perfect. And I'm glad you all gave all of the examples. Thank you for sharing that. Like, very important, critical information. I know we have somebody here from Solar Turbines, so he will be taking that into consideration as well in terms of power plants. I have Joaquin asking a question about, he recently facilitated an alignment of an alternator on a ship, and the alignment procedure proposed the dial indicator method, and he recommended the laser method instead. What are your thoughts on laser versus dial indicator method? He said the limit was 0.002. I know it's a huge technical question and we need context, but I'm putting it out to the experts.
Yeah, so I don't think we can answer that question right here.
Right
but
now, I hear you, Joaquin.
Send an email.
Send an email to them.
Take a look at some
check
of
their email addresses there, and send an email to them, because I know you all will both have a lot of things to talk about, because Joaquin has some stories to share. So
Yes,
I
and feel free to email us any questions.
Yeah,
We're
we can-
happy to receive.
definitely.
Yeah, we can consult with our other internal teams who might have a bit more of a say in this matter to to
Oh,
advise.
yeah. All right. So I want to thank you guys for sharing all that information about BELCO, and the case study is very helpful. This will be recorded for those of you who missed parts of it, but check out some of the other sessions that we have coming up. I know we have another session starting right away. So thank you all so much for your time, and we will be seeing you all soon. If you haven't jumped on the leaderboard yet, please try and do so. I see the points are just going up very quickly. So check that out. All right. Bye.
All right,
All right,
thank
thank
you.
you.